drift velocity. It's nothing but the velocity with which the electrons inside the conductor will be moving. Take a situation. Say you have a conductor here and an electric field E is applied in this direction. Of course, the electrons are negative charged particles, so they move in this direction. So, the charge on an electron is minus E, where E is 1.6 into 10 power minus 19 coulombs, and the electric field is E. So, this gives me the Coulombic force on the electron. Now, if I divide this force with mass of an electron, that gives me the acceleration, because by Newton's second law, F is equal to ma, the force by mass gives me the acceleration. So, this is the acceleration, right? Say the time period between two collisions is tau. I'll explain you in detail. Inside a conductor, what happens is there will be a lot of electrons here, and every electron is moving in some random direction, and there will be many collisions taking place due to this movement. The average time between two consecutive collisions be tau. So this gives me the drift velocity, I should say, because you know that v is equal to u plus at. This is the formula to calculate the velocity when you have constant acceleration. This is the acceleration and this is the time. As said, this time is the time between two collisions, which is also sometimes called as relaxation time. So this is the drift velocity. Now you may get a doubt. What about this u? See, there are many electrons and they are moving very randomly. So although some electrons have this direction of their velocity and some other electrons have this direction as their velocity, on an average, if no electric field is applied, I can assume the vectorial sum of all these velocities to be 0. So before applying the electric field, the thermal velocity of all these electrons can be approximated to 0. That's why you don't count this u, and this acceleration into this time gives you the drift velocity. Hope everything is clear till now. Interestingly, this drift velocity is independent of time. This tau is constant, m is constant, d is constant, and e is what you apply. There is no time factor in it. And the negative sign here indicates that the direction of the electron is opposite to the direction of electric field. Let's move forward. Take a situation. I have a conductor here, and I want to see what happens at this cross-sectional area over a time t. Now observe this. Say I have an electron here. After a time delta t, this electron, of course, electric field is in this direction, and the electron will be moving in this direction with a speed vd, drift velocity, and after a time delta t, this is the distance traveled by the electron, right? So from this surface, say the electron which was at a distance of v delta t would have crossed this surface just after time delta t. Have you understood this? So I can say that all the electrons which were present in this area from this surface and this surface, which is at a distance of vd delta t, all the electrons in this area would have crossed this surface which I am interested in. So how many electrons are there in this surface? Let me introduce you to a new term, n. N is nothing but the number of electrons per unit volume. Now what is the volume of this region? If the cross sectional area is a, this is the length, right? Vd into delta t, and area is this one. So this is the volume of this region which I am interested in, and this is the volume. This volume times n gives me the total number of electrons in this region, and I know the number of electrons now. If I multiply that with charge of each electron, that gives me the total charge that has been total charge that has crossed this surface which I am interested in. So this much amount of charge has crossed the surface in the time delta t. Let me write it again. This much amount of negative charge, E is 1.6 into 10 power minus 19, and let me write this one as mod vdt. So this is the negative charge that has been transported from right to left. Hence the negative of this will be the positive charge that has been transported from left to right, I should say. And you know that the current is nothing but the rate of charge transported. So if I is equal to q by t, then my q will be I into t, right? So this is my charge, which will be nothing but the current that is flowing into the time. What is time? Delta t. So if this delta t and delta t gets cancelled, I can say my current is NEA mod Vd, where Vd is drift velocity, N is the number of electrons per unit volume, and A is the cross sectional area. And if I write the Vd as small e capital E by m into tau, I can write the same thing as capital I is equal to E square A by m into tau n mod E. I just replace this Vd with the formula of Vd, which was in the previous slide. Now observe this. You know that current density is current by area. So current will be current density into area by definition, of course. And current density from this formula of previous slide can be written as I by A is equal to E square by m tau n mod E. I hope everything is clear till now. Now from these two equations I can write this one, right? E square by m tau n mod E. Now this appears similar to me because in the Ohm's law I wrote like J is equal to sigma E. This is something similar to this, right? Observe the similarity. What can we infer from this? This is Ohm's law and this is what we derived now. So from this I can infer that the sigma, the conductivity, is nothing but E square tau n by m, where m is the mass of electron and n is the number of electrons per unit volume, and tau, as you know, is a constant. It is the time between two consecutive collisions. Hope everything is clear till now. Let me explain you one more term. It is mobility. Now how should I explain you? See, if you have a conductor, initially the electrons were at rest. I mean, approximately their velocities can be summed up to 0, as I said you before. If I give an electric field here, then the electrons will be drifted right in this direction. If I increase the magnitude of electric field, then what? The drift velocity also increases. Electrons move even more faster. So our intuition says that this electric field is proportional to the magnitude of drift velocity. Hope everything is clear till now. And to remove this proportionality symbol, I'll put a constant. That is nothing but 1 by mu, where mu is the mobility, or in other terms I can write this Vd is nothing but mu into E, where mu is the mobility. It has the units what? Meter square per volt per second. These are the units for mobility. And actually mobility is expressed in terms of centimeter square per volt per second. And there's one more thing. You know that drift velocity's magnitude is small e capital E tau by m, where m is the mass of electron and all that stuff. Now you just replace it here, put this one here, tau, and the capital E gets cancelled. You get mobility as small e tau by m. And make sure that mobility is always greater than 0. Don't ask me why, even I don't know that. Let's move forward. Let us solve a small question. I want to calculate the average drift speed of the electrons present in this conductor. Given data is that the cross sectional area is 10 power minus 7 meter square, and the current through this is I is equal to 1.5 amperes, and this is a copper. This is copper. Given that the density of copper is 9 into 10 cube kg per meter cube, and I have to calculate the average drift speed of the electrons, of the conduction electrons. Now we know that the formula for drift speed is I by NEA from the above calculation. They gave you the current, they gave you the area, and you know that E is 1.6 into 10 power minus 19 coulomb. Now, if I find this N, the game is over, right? Now, this is the question: how to find the N? N is the number of electrons per unit volume. See, given they gave that the density of copper is 9 into 10 cube kg per meter cube. Now, I know that the atomic mass of copper is 63.5 AMU, atomic mass units. It means that 1 mole of copper is 63.5 grams. 1 mole of copper contains 6.023 into 10 power 23, that is the Avogadro number of atoms. Now, these many copper atoms weigh 63.5 grams, right? So, how many atoms will weigh 9 into 10 power 3 kgs? This is my question. 9 into 10 power 3 kgs means 9 into 10 power 6 grams. And to get the number of atoms, what I'll do? I'll divide by this 63.5 and multiply with 6.023 into 10 power 23. So these are the number of atoms in 1 meter cube of copper. Now this is not N, these are not the number of electrons. Of course, simplify this term, you will get something like 8.5 into 10 power 28 per meter cube. Okay. Now I have 8.5 into 10 power 28 atoms per meter cube. Now the copper has the atomic number 29, right? So by its electric configuration, each copper atom can give 1 electron. So taking 1 electron from each atom, I have these many atoms. So my number of electrons in 1 meter cube will also be the same number, 8.5 into 10 power 28. So now you got the number of electrons per unit volume, right? Just put this value also in this formula, and finally you will get the drift velocity to be some 1.1 millimeter per second. Now, don't you think this is very small? 1.1 millimeter. Actually, the values which we have given here, the area, the current, the density, all these are typical values. So even this velocity should be the typical answer, right? Actually, that is true. Electrons are in fact so slow, that is they are slower than tortoise. Now you should get a doubt. If electrons are so slow, then how is it that the bulb glows almost instantaneously when you switch on in your room? Actually, see what happens here. If you have a conductor here, when you switch on the light or bulb, the electrons don't have to move all this distance, but the electric field inside this is set almost instantaneously. Actually, it is set with the speed of light. So the electric field is set very fast, very fast. So all the electrons which are present at their respective positions start moving together. Hence there is a current almost within a fraction of a second. And even the charge transfer that we got is reasonable in amount because of this guy. And because although the drift velocity of electrons is very low, and although the charge on an electron is very low, that is some order of 10 power minus 19, right? Still, the number of free electrons in this material per unit volume, that is very high. You see this somewhere of the order 10 power 28, 10 power 29. This is able to compensate all the other effects and finally give us some reasonable current. Hope you enjoyed this video. That's it for today. Keep watching.